Let's do another example. So here we are interested in finding the true proportion of people who have a pet to combat depression. So we sampled 50 people and found that 24 of them own a pet to help their depression. So find a 99% confidence interval estimate and interpret the interval. So if you want, you can go ahead and try it out based on the notes that you've been taking. And I'm just going to go ahead and just do it. So because we want a confidence interval estimate, well, we know that we're dealing with proportions, so it's going to be p hat plus or minus z star square root of p hat 1 minus p hat divided by n. All right, so we want a 99% confidence interval, so let's see what our z star should be. So our z star, let me go back up. So we look for 99% confidence. 99% confidence corresponds with 2.575. Okay, so here our z star is going to be 2.575. The number of samples that we've gathered was 50. Okay. Now, p hat, notice that p hat was not given to us this time. And if you go back up, here our p hat was already given to us. We said that from 100 people, 60% of them had a birthday in September. In this case, we do not have the percentage, but we can try to calculate it because we know that all we got to figure out the proportion is just to find the proportion of people who own a pet. So here is 24 out of this 50. So 24 out of this 50, well, the proportion in this case is going to be what? It's going to be 0.48, okay? So now that we have all of this, now we can go ahead and plug it into our formula and then figure out what the confidence interval estimate will be. So we're going to have p hat plus z star square root of p hat 1 minus p hat divided by n. And I'm also going to have p hat minus z star square root of p hat 1 minus p hat divided by n. Okay, so let's plug in all of these things into our formula. So we have 0.48 plus z star, which is 2.575, square root of 0.48, 1 minus 0.48 divided by n, and in this case is 50. Okay. And then here I'm going to have 0.48 minus 2.575 square root of 0.48, 1 minus 0.48 divided by 50. Okay. So literally put all of that into your calculator just how it looks like. So we're going to have 0.48 plus 2.575 square root of 0.48, 1 minus 0.48 divided by 50. This top one I get about 0.662, and on the bottom one we're gonna do the same exact thing, but now we're gonna change the plus to a minus. Let me see. Here you go. All right, so this bottom part, and as you saw, Domino's Pizza. Okay, so 0.298. Okay. All right, so here are my confidence interval estimates. So it's going to be between 0.298 all the way to 0.662. Okay, so this is, if you want to put it as a percent, that's fine, 29.8% all the way to 66.2%. Okay. All right, now interpret, because we got to interpret it. Interpretation. So what exactly does this mean? So it says we are how percent confident? We are 99% confident that the true proportion of what? True proportion of people who own a pet for depression lies between 0.298 and 0.662. Yes, you do have to write it. Okay, you have to write all of that. Okay, so it's very self-explanatory. Plug things into the formula, put it in the calculator, keep track of your z star, and that's basically all it is. Okay, so now right before we end, let me give you a couple of of notes about confidence intervals. Notice that with the higher confidence implies a wider interval. And that's what technically happens, because if you look at our 95% confidence interval, 50% and 69%, they were somewhat around the same ballpark. But if notice that when I increased my confidence interval to 99%, it made it much wider, because this one now is between 29% to 66%. And that makes sense, right? Because our z value is actually much more larger. Our multiplier, this z, is much more higher than our 1.96, which kind of made it a little bit more wider. Okay? So, which means it's not really, the range of values is not really accurate now, okay? Because now, well, it is really accurate, you just have more range of values to choose from. So it's not very helpful. A larger sample size will narrow your interval. So if you get many samples, if n increases, then your interval is gonna, interval is going to decrease in the width. Okay, and that makes sense, because if you're getting larger and larger so that you have all of the people in the population, then you're going to get closer and closer to your estimate. Confidence intervals are interval estimates for your population parameter P. So remember, we don't know what P is, so we're trying to estimate it. So the confidence interval is only for the population parameter P, not for P hat, not for anything else, for P. Values not covered by your interval are still possible, but not very likely. So for example, for this type of interval, 28% is probably still possible, right? But it's probably not going to be very likely. So here we're just including the likelihood of me having this this true value of P lie within the interval. That doesn't mean that the other values cannot be part of the interval. They're just not as likely based on my samples. Okay, and that's basically it. We'll do a couple more problems for this. For the quiz, I will on Tuesday, I will quiz you on central limit theorem. So you don't have to calculate anything. It'll be very basic, just finding the sampling distribution, which is what we did. Where is it? Which is what we did up here. So basically something like part B. Nothing too terrible. Okay, that's it.